So what is being said in this question? We have represented it here. It says that a mountaineer starts from the bottom of a mountain, base of a mountain at 4 a.m. in the morning. He travels different distances at different times, and then at 8 a.m. he reaches the top of the summit. So the question asked is, find the average speed for the entire journey from bottom to the top. So at 4 a.m. he was at the bottom, and at 8 a.m. he was at the top of the mountain. So we have to find out the average speed for this journey from the base of the mountain to the top of the mountain, and we have to also tell about the average speed for each of these hours. So let's start doing it. The first question is to calculate the average speed for journey from bottom to top. What was this formula for average speed? It was total distance divided by total time. This was the formula for average speed. What is the total distance that he travels? He travels 100 meters in the first hour, then 350, then 250, and then 100. So it's 200, 200 and 500 is 700 and 800. So he travels a total of 800 meters in how many hours? 1, 2, 3 and 4 hours. So 800 meters by 4 hours. So you can convert it into kilometers. So it's 0.8 kilometers by 4 hours. So it will be what? 0.2. If you want me to write it here, it will be 0.2 kilometers per hour. So his speed is going to be, average speed is going to be 0.2 kilometers per hour. What can you say about the average speed for each of these time intervals? For 4 to 5 am, the time elapsed is 1 hour and the distance moved is 100 meters or 0.1 kilometers. So the average speed from 4 to 5 am will be the total distance, that is 0.1 kilometers divided by 1 hour, that's 0.1 kilometers per hour. Similarly, you can calculate this average speed for 5 to 6 am, which is 0.35 divided by 1 hour, that's 0.35 kilometers per hour. Similarly, S67 will be how much? 0.25 kilometers per hour, and S728 will be how much? 100 meters it travels. So it will be again 0.1 kilometers per hour. So you see that the average speed for the whole journey was 0.2 kilometers per hour, but for each of these intervals it is changing. Hence we can say that this is an example of a motion of non-uniform motion, because the speed in different intervals is different. The speed in different intervals is not equal to the average speed. So only in case that average speed is equal to the speed in all the other intervals, whatever that interval might be, is the motion is going to be called uniform. So it's not a case of uniform motion, it's a case of non-uniform speed. Now for a body traveling with uniform speed, the speed at any instant is equal to the average speed. For a body that moves with uniform speed, the uniform speed is going to be the same as the average speed for the whole journey. But the same is not going to be the case in the case of non-uniform speed. For a non-uniform speed, its value is not going to be the same as the average speed at all points of time. And as I said, the speedometer of the car gives you the instantaneous speed. If that was speed, what is velocity? Velocity of a body is the speed moving in a definite direction. Just as in the case of distance and displacement, you have speed and velocity. Speed just gives you The degree, it just informs you about the overall rapidity of the motion. It just doesn't tell you anything about the direction. Velocity is what tells you about the direction. So you would know in which direction you are moving. When I say that I am moving with a speed of 20 meters per second, you would not know in which direction am I headed to. But when I describe velocity, I would say I am moving 20 meters per second due east. That means we are moving towards the east with a speed of 20 meters per second. So if we bring back the concept of scalar and vector here, what would speed be? Speed will be a scalar quantity, whereas velocity will be a vector quantity, because velocity has both magnitude as well as sense of direction involved in it. So the speed is a scalar quantity and velocity is a vector quantity here. The velocity of a body can change if you change its magnitude or its direction, or both of them simultaneously, we change them together. So the velocity of a body can, even if a body moves with a constant speed, it could still be a case of changing velocity. For example, in a motion along a circular path, if the body is moving with a speed of 20 meters per second along the circular path, it would mean the speed remains constant, uniform throughout his movement along the circle. So he moves 20 meters per second, so he moves 20 meters in 1 second as he moves around the circle. But will his velocity also be called uniform velocity? It will not be called, because his direction keeps changing as he moves in a circular path. At each point of his motion, the direction of velocity, direction of motion is going to be along a tangent that you can draw at that circle. So the motion, as he continues with the motion along the circular path, his direction is going to continuously change, and vector also is associated with direction. Hence the velocity will keep on changing even though the value of speed is not changing. So remember that velocity of a body can be changed by changing its magnitude, that is by changing the speed, or by changing the direction of motion, or by changing both of them together. The velocity is defined as the total displacement divided by time. So velocity is written as displacement by time, and unit of velocity is same as unit of speed, because the magnitude wise they both are going to be the same. So velocity is going to be, the unit for velocity is going to be meters per second. The displacement's unit is also meters. Now you have this particular body, you have a straight line path. Again, as in the case of prescribing or describing the position of a particle, you had to choose the origin, you had to choose the positive direction, and you had to choose the negative direction. The same, what is uniform velocity? Like in the case of uniform speed, uniform velocity is not going to be, the velocity is not going to be the same as uniform velocity. Uniform speed and uniform velocity are different, because velocity can also be changed by changing the direction. Hence uniform velocity, if the velocity of the body does not change with time, it is said to be moving with uniform velocity. That means a body getting displaced equally in equal intervals of time in the same direction is said to be moving with a uniform velocity. Differences between speed and velocity, I think you will be able to appreciate it better now. So the speed just gives you is the distance covered by a body in a given time interval, whereas velocity is the displacement of a body in given time interval. The speed is a scalar quantity, whereas velocity is a vector quantity. The average speed of a moving body can never be 0, because average speed is always the total distance by total time, and total distance in case of a moving body can never be 0. Whereas the average velocity of a body can be 0 if the displacement is 0. If I move from point A to B along a straight line path and come back to A, then the displacement would be 0, and hence the average velocity would be 0 for me. So average speed can never be 0 for a moving body, whereas the average velocity can be 0 for a moving body. Speed gives an idea about the rapidity of motion, whereas velocity gives you an idea about the rapidity as well as position of the object in motion, because there is a sense of direction involved, so you would know where the object is at the end of the journey. And a speed of a moving body along a straight line can never be negative. Speed can never be negative, again because the distance can never be negative, so speed cannot be negative. Whereas displacement can be negative owing to the sign convention that we use. If we move to the negative of the origin, then the displacement is going to be negative, and hence subsequently the velocity is also going to be negative, because velocity is what? Displacement by time. So velocity can be negative, it just gives you a sense of the direction. Speed can never be negative because there is no sense of direction involved here, it's just the magnitude, and the distance can either be 0 when the body is at rest, or it could be a finite value greater than 0, hence speed can never be 0. So these are the basic differences between speed and velocity. So now this question is again covers the basic thing. You are moving from New Delhi to Panipat. We are going to assume that it's going to be a one-dimensional motion, a straight line motion. So the distance is 100 kilometers. While going it takes 1 hour 30 minutes, and the return journey will take 1 hour and 15 minutes. So what is the first question? The first question that is being asked is average speed and average velocity for the journey from New Delhi to Panipat. So for part A, the average speed will be equal to average velocity. Why? It's a straight line path and there is no turning back. It's just moving from point A to point B along a straight line path, and only in this case is the distance going to be same as displacement. And average speed is what? Total distance by total time. And average velocity is what? Total displacement by total time. And in this case, when the bus moves from New Delhi to Panipat, the distance, the total distance and total displacement are going to be the same. Hence the speed and average velocity are going to be the same. And what will its value be? 100 kilometers. You convert 1 hour 30 minutes into hours, so it will be 1.5 hours, which is, you get what? 3, you have 200, that's 66.67 kilometers per hour. So this is going to be the average speed or average velocity for the journey from New Delhi to Panipat. And what will be the average speed for the round trip? Round trip is going from New Delhi to Panipat and coming back from Panipat to Delhi. So in this case, the distance is equal to 100 plus 100, and the time is going to be 1 hour 30 minutes plus 1 hour 15 minutes. So 2 hour 45 minutes is going to be the time. So it's going to be, the numerical value is going to be 200. 2 hours and 45 minutes is 3/4 of an hour. So it's going to be 3 by 4 hours, and this is kilometers. What do you get? You get 200 divided by how much? 11 by 4, that's 200 into 4 by 11, it's 800 by, that's going to come out to be 72.7, isn't it? Yeah. This is going to be the average speed for the to and fro journey, that's the round trip, and average velocity will be 0 because once he moves from A to the point B and from B to point A, the total displacement is going to be 0, and hence the average velocity for the round trip is going to be 0. So in this case, the average speed and average velocity will be different. In the first case, they were same because the journey was along a straight line path and only in one direction.